This video is your standard deviation part 2 notes. You may want a calculator, otherwise you'd have your notes packet and a pencil ready to go. So as we were looking through standard deviation, we were determining the spread of the data. And so today we're going to relate standard deviation to a histogram and to a normal curve. So if we look at this histogram, we could say that it's fairly normal, maybe slightly skewed with more data points here on the right, but it's still pretty normal. And when I calculated the standard deviation, first of all, the mean was 76 and the standard deviation was 6. So on average, every test score was 6 points away from the mean. And so what we can do is we can trace the outline of the histogram, take the histogram bars away, and when we do this, we renumber the x-axis in terms of the mean and the standard deviation. So on your normal curve, I'd like you to label 76 in the middle, and make note that that is your mean, and we add 6 to each standard deviation. So these tick marks on the x-axis is the number of standard deviations you are away. So this next tick mark would have a representation of 82 and then 88. And then going to the left, we would subtract 6, so we'd have 70 and 64. And so that's the mean is here in the middle with x bar. 82 is 1 standard deviation to the right. 88 is 2 standard deviations. Remember, this lowercase cursive o is our standard deviation symbol. 70 is negative 1 standard deviations to the left, and 64 is negative 2 standard deviations. And so that's what we're going to focus on, is 2 standard deviations to the right and 2 to the left. You can go out to 3 standard deviations as the curve extends to there, but we're going to focus on these for now. So, a little vocabulary here. For normal distributions, approximately 68% of all data falls within 1 standard deviation above and below the mean. And for normal distributions, approximately 95%, so almost all of the data falls within 2 standard deviations of the mean. So let's look at what that looks like on the normal curve. So when you have your normal curve, we can divide these out into groups here. So we can break the normal curve into sections. A little bit of a crooked line there. And so when we do that, we can label then that these are like broken into our standard deviations. Okay, so I have our mean in the middle, 1 standard deviation, 2 standard deviations, negative 1, negative 2. And so we can divide this curve out. Okay, so let's think about what we just wrote down. We said that 68% of the data is within 1 standard deviation. So all of this area here would be 68% of the data. All of this area here. And then within 2 standard deviations, that would be 95% of the data. So all you have remaining is just a little bit on the left and the right, and we would know that that whole curve would be 100% of the data. So we can break down each of these bars into individual chunks. So if we know that within 1 standard deviation on each side is 68%, then we can label each portion of the curve. So what I need you to remember or commit to memory is that this is 68%, and within 2 standard deviation is 95%, and then we can calculate and fill in the rest of them, okay? So the first thing, it's easy to divide the 68 into two parts. So this bar then has 34% of the data, and this bar is 34% of the data because 68 divided by 2 is 34 and 34. And then moving on, we can say, okay, if this whole chunk was 95%, we could take 95 minus the 68, and that leaves us with 27% for both this section and this section. So if we then divide that by 2, we then can say, okay, that this bar has 13.5% of the data, and this bar also then has 13.5% of the data. And then lastly, if we know this whole area is 95, we can take, obviously our whole curve is 100 minus 95. That leaves us with 5% for the little tails on each side, and then that would divide by 2, leaving us with 2.5% in this little piece here and 2.5% in this little piece here. So again, I need you to commit to the 95 and the 68 to memory, and you can calculate and label these percentages. So if you turn the page in your notes packet, we have a few examples to go through, and let's practice applying this material. So example number 2. First of all, we're just going to practice labeling this normal curve. So then I might have problems for you where I tell you that the mean is 20 and the standard deviation is 2. And so the first step to do that, we would just simply label 20 in the center, and we add 2 to the right, so then this becomes 22 and 24, and we subtract 2 to the left, so then this standard deviation is 18 and 16. Remember, the mean is always in the center there, okay? And so moving on to example number 3, it says, what percentage of the data falls between 18 and 22? So at this point, if you're now going to answer questions about this curve, we could fill in our values. So within each standard deviation away, remember that this is 68%, and so we could divide this up into our 34 and 34, and then all the way from 16 to 24 is 95%. So remember that this is 13.5 and 13.5. And then we have 2.5% on each tail. And so now we can answer these questions. What percent of the data falls between 18 and 22? And that's our 68%. What percentage of the data falls between 16 and 24? That's all the way 2 standard deviations. That's that other number we like to memorize. 2 standard deviations away is 95%. What percentage of the data falls above 24? So I'm looking at this cutoff here. Above 24 is only 2.5%. And lastly here, what percent of data falls below 20? So 20 is the mean. You could take time and add these 3 numbers up, but remember the mean is directly in the middle here. And so above and below the mean is always going to be 50%. That's stuff that we will become easier for us. All right, last example here, example 4. So use the curve provided to answer the following questions. What is the mean of the data set? So when we're looking at this curve, we know the mean is in the middle, so our mean is 78. What is the standard deviation? So we'd look and see the difference between each tick mark, and we can see that we're increasing by 8. Now let's answer these questions. What percentage of the data falls between 70 and 78? So if I'm going to answer these questions, we'd want to label our curve. Go ahead and hit pause and label these percentages. Hit play when you're ready. All right, so let's see how we did. So we break this in half or divide all these percentages out. And maybe some of you are starting to have this memorized. All right, 68%. We know that we have a 34 and 34. 95% minus 68 leaves me with 27. I divide by 2, leaving me 13.5 on each side there. And lastly, our tails are 2.5. And so to check these questions out then, what percent between 70 and 78? That would be 34%. What percentage of data is between 62 and 78? So we're going to add 13.5 plus 34, and we'll see that that is 47.5%. What percentage of data is above 86? That's going to be 13.5 plus 2.5, which is 16%. What percentage of the data is above 70? So there's two ways you could do this. You could add up those four values, or you could say that this chunk we've already figured out on the other side was 16. We could say 100 minus 16% leaves us with 84% for those other four areas. And what percentage of the data falls above 62? So again, I think the easiest way to find that answer is say, okay, the whole curve is 100. Let's subtract off that 2.5, and we're left with 97.5%. So there's your introduction to the normal curve, breaking them out into percentages, and now you'll be ready to practice this material.